Good afternoon, everybody. Thanks for the opportunity to be here and the warm welcome. I really appreciate it. So my research lab in the Division of Comparative Medicine at MIT studies bacteria, microbes, and how they influence your good health. Well, as we were doing the studies with microbes, testing them in different settings, we discovered some amazing things, and I'd like to share those things with you this afternoon. A little more than a month ago, the New York Times featured some work that was done in my lab, and it was called Microbes, a Love Story. It was a story with adventure and intrigue, romance. It involved reproductive fitness. It involved the intense bonds between a mother and a newborn baby. And it involved what it means to be human. So the story, Microbes, a Love Story, has some stars. One of them, the gut bacteria that live inside of you. Another one, a hormone, love hormone, oxytocin. And you, all of you, and your good health are a star in the story. So let's talk a little bit about what health is. And it's a very difficult thing to define. I think most people think of it as the absence of being sick. So the absence of disease is good health. But good health can be a lot more than that. There may be more than even just physical manifestations. There can be mental health and social health and even spiritual health. Maybe this is a gateway to a more meaningful human existence. And we probed some of those questions with our research. So I think this has become a very popular topic, and most of you realize that you're filled with microbes. And those microbes become part of who you are. They're a unique part of who you are, as unique as fingerprints. You pick up many of them early in life. You influence them with different things that you do as you're growing and as you become an adult. Most people like to think of bacteria as bad, but really a lot of these bacteria are an important part of your well-being, an important part of who you are, and there's trillions of them. In fact, there's so many that if bacteria were oranges, you stack them up one on top of another, they would extend all the way through our solar system from the sun to beyond Pluto. That's how many bacteria are in your body. You're basically like a walking sack of bacteria. And my collaborator at MIT and his lab took this very seriously, and they decided they were going to thoroughly characterize their personal microbiome. And so this involved collecting their poop every day for 365 days. And the stories I could tell would take the entire 18 minutes, and so I'm not going to do all of that. But they discovered some very interesting things. And one of the things that they discovered is that the microbiome, the microbial communities in your body actually flux. They change almost on a daily basis, and they change according to things you eat and things in your environment and activities that you participate in. Sometimes those changes are subtle, and sometimes they're more dramatic. It doesn't mean you're getting rid of all your old microbiomes and taking on new ones. It means rather that the populations go up and down in number. And one of the interesting consequences of this is the idea that the foods you eat influence the balance of the microbes in your body. And this is an incredibly intriguing and powerful concept. So right around the time that my collaborator was collecting his poop every day, some work came out from Harvard School of Public Health, and they were actually looking at human subjects and the things that human subjects eat and the activities that they participate in over time. And one of the really interesting things that they discovered was that the food that people were eating was impacting their health and how much weight they gained over time. So they explored all these food diaries. They had a lot of hypotheses. And some of the things that they were proposing at the beginning of the study turned out to be pretty insightful and probably not that surprising. If the participants ate a lot of potato chips or a lot of French fries, for example, they were more inclined to gain weight over time. What the authors had speculated was that at the other end of the continuum would be things like eating a lot of vegetables or doing a lot of daily exercise. But it turned out, even more than eating a lot of vegetables, which was quite a healthy thing to do, or having a lot of exercise, it was the people who ate yogurt that maintained their body weight and were the most slender at the end of the study. And this is fascinating. And so we were putting two and two together, and we're thinking, well, maybe there's some connection between the foodstuffs and the microbes, and we went on to explore that a little bit further. So we set up some studies in mouse models, and we used mouse models because there are a lot of things that you can study in a mouse model system that are very, very challenging to study in human subjects. We could have fed human subjects this delicious fast food menu, but we didn't. Instead, we fed it to the mice. And we had another subset of mice that were eating yogurt. A lot of people ask, what yogurt? That's vanilla. They really liked it a lot. We would put the cup in and they would go running over. They did have a regular diet in addition to that, but they were supplemented with yogurt. So one of the things that we found in the series of experiments was that there was an enormous difference in the body weights of the animals that participated in the experiments, and it was very much like what was seen in the human subjects. So you might notice a fast food mouse off to the right center there was a little thicker around the midsection. and the animals that were eating the probiotic yogurt were more slender. And we went on to examine this in a lot more detail because we had a hypothesis that it was actually the bacterial component of these diets and how the bacterial were blooming in the intestinal tract that was influencing the physiology of the animal and giving us these fabulous slenderizing results. So in order to study this in a pure scientific kind of way, we had to pick a microbe. We had to decide, out of these trillions of microbes that humans carry, we were looking for a good candidate. And we chose one called Lactobacillus reuteri, which comes from human breast milk. This particular isolate was from human breast milk. And it wasn't a random choice on our part. We were very fortunate in that we saw striking results, but the choice was based on a number of things. First of all, it had originally come from a human subject, and it was from breast milk in particular, which was interesting to us because of the potential relevancy with early life. As it turns out, Lactobacillus reuteri it's believed, used to be very, very common in people, widespread across the world. And with our modernized practices, there are many of them, treating with antibiotics, sterile hospital births, refined foods, that Lactobacillus reuteri is much less common than it used to be. In fact, if they surveyed today, about 4% of people across the world are actually naturally carrying this organism. So we thought, well, this is a really interesting model system to work with. And then on top of that, Lactobacillus reuteri actually has decades of published data in helping human intestines stay healthy. So it treats diarrhea, it stops stomach ache in young people and in old people, and all of this seemed like good reasons to use this as a model organism. The mother-infant bond potentially offers a lot of clues to our good health, and this motivated us too. So we went on to do studies in mice. We fed the mice purified bacteria in the drinking water, and we recreated all of the results from the earlier yogurt lapping mice that you saw in the video. And in those studies, the purified bacteria were actually more powerful than the probiotic yogurt in terms of slenderizing the animals. And so our conclusion, based on this first portion of experiments that we call "you are what you eat," sort of, is that the beneficial bacteria are playing very important roles in the outcomes of the things that we eat. So a very common question that I'm asked is, well, you saw these results. Did you do anything differently with your own life? And I absolutely did. I'm like, who doesn't want to be slimmer, right? You don't want to, yeah. So I thought, all right, I'm going to give this a shot, and I'm going to try eating more probiotic yogurt than I was eating before. And one side benefit to that was that our dogs, this is one of our pet dogs, Julio, cleaned out the yogurt containers after I was done eating out of them. As we're progressing through these studies in the laboratory, I have a very astute technician. Her name's Tatiana Levkovich. And Tatiana was taking care of the mice. And this is a picture of the actual groups of mice that she was looking at. And she made the observation, just sort of casually, when asked, how's everything going? And she says, those are the shiniest mice I've ever seen. And I'm sitting there thinking about it, and all of a sudden it occurs to me, I'm eating yogurt and I'm pretty shiny. All of my dogs are eating yogurt, and they're really shiny too. In fact, so shiny that people often comment on it. The dog off to the right, that's Zappy, and she's very shiny. So we thought, maybe there's something to all of this. And so we started to examine skin sections from the mice that were eating the probiotic or not, and we discovered amazing things. So this was not something that we set out to do from the beginning of the studies. This was based on this observation of the technician and us realizing that there's a really interesting underlying story. So as you look at the skin sections, you probably, even if you're not someone who looks at skin sections all the time, would probably realize there are differences between the control and the probiotic-treated animal. And those differences are that the skin is much thicker. It turns out this is a manifestation of being healthier skin, but those large purple spots that you see in the probiotic-treated group, those are hair follicles. And there was a massive amount of new healthy hair growing out of the skin of the mice that were eating the probiotics. It's just fascinating. So it turns out when you shave the fur off of mice that are controls or those that are eating probiotics, that the hair grows back thick and shiny and lustrous in the animals that are eating the probiotics. And we call this phenomenon the glow of good health. And it was so pronounced that these mice are genetically identical. Everything that they were doing was equivalent. And in spite of all of our presumptions that the only time you could make changes in your microbiome or health was when you were very young, these mice all started on the experiments when they were much older. And the differences were still really dramatic. They were more slender, they had this fabulously shiny hair, and it turns out there's more to it than that. So we were doing research studies at MIT, and we recruited a group of human subjects who were interested in learning more about the glow of health. And oh, by the way, having a small skin biopsy was one of the things that we wanted to do. And all the volunteers were very enthusiastic, the human volunteers, and we had some mouse participants as well. And we were interested in knowing, is the skin really healthier, and how could you measure that? So one of the things that we did was a skin biopsy to see how quickly the skin would regrow over an injury site. If you think about this, it's potentially really important how quickly your skin closes after an injury, because if it's skin on the outside of your body, it's keeping out the external environment, and it's protecting you more quickly and more effectively if it heals rapidly. If it's inside your body on one of your mucosal surfaces, it potentially acts as a barrier from potentially bad infectious agents that could make you sick. So we discovered some really interesting things when we started doing the skin biopsies. Both the human subjects and the mouse subjects recovered very, very rapidly if they were eating the probiotics. It could be the probiotic yogurt, or it could be the purified probiotic bacteria. But we discovered some interesting things about the underlying mechanism as well. One of those things was that the interactions between the bacteria that the animals or the people were consuming and the manifestations of their skin were actually part of a complicated axis between the gut and the brain. And the brain was producing a hormone called oxytocin, the love hormone. So as we started to tie together the mechanistic underpinnings, we discovered some really interesting things with some profound implications. So if we return for just a moment to the idea that we might have discovered a gateway to something that has a profound consequence on our well-being at every level, let's talk about microbes and oxytocin for a minute in that context. There are decades of publications on human subjects and animal models looking at oxytocin in an inhaled form, in an injectable form, or simply native levels that link it very convincingly with physical well-being, mental well-being, and social well-being. This is the same hormone that bonds moms closely to their babies during breastfeeding. It's the same hormone that keeps friends tightly bonded and is the basis for romantic relationships. And it has spiritual implications as well, suggesting that if we knew how to harness this, and I would be the first to admit, we have way more questions than answers, but if we could harness this, we might be able to experience a very meaningful human existence beyond anything that we've ever imagined. So oxytocin equals good health in a lot of ways. This is Ned sitting on the couch, and all the way over on the right, that's Madam Squiblet. And all of these dogs are experiencing the part of the well-being of the microbe-induced oxytocin and good health. The microbe stimulating oxytocin in the brain, that raising the levels of oxytocin in the body, and then all of the health manifestations that result from that. So we did a final set of experiments where we were following up on an interesting observation that the older brother mice that had very similar genetics, that had been housed identically, were actually almost the counterpart of elderly mice, looked dramatically different if they were eating the probiotic or not. And how did they look different, you might ask? They had this presentation that we call mouse swagger, but only if they were eating the probiotics. So if they were eating the purified bacteria or the yogurt, then they had the swagger. And we called this great balls of fire. So it had interesting other implications. The testosterone levels were high. The sperm production was very high. And these males were able to fertilize young females and parent far into old age. So even internationally, everyone was very interested in all of this element of romance. And this is all in Italian, so I'll translate it for you. And that's basically, we believe that all of these manifestations are really what health can be. And there are, of course, some age limitations, but some of the age limitations were things that really surprised us. We had preconceived ideas that it was only a youngster, and in fact, this could work on older animals. You might wonder how you can get that. I'm glad to answer questions after the presentation. You can make this your own love story. You have the ability to be what you want to be. And with the science that's emerging, you make this story your own. Thank you very much, everybody.